Molar heat capacity is an important chemical property. It refers to the amount of energy required to raise 1 mole of a substance by 1 degree Celsius. Let's take this question for example. Determine the amount of energy required in joules needed to warm 250 grams of water from 10 degrees Celsius to 80 degrees Celsius. Let's start by listing what we know. The molar heat capacity of water is 75.3 joules per mole degree Celsius, and we have 250 grams of water. The equation to determine the amount of joules needed to raise the temperature of water is Q equals molar heat capacity times moles times delta T, where Q is the energy required and delta T is the change in temperature. Step 1. Remember Units must match. Therefore, we need to convert the mass of water into moles because the heat capacity of water is given in moles. We do this by dividing the mass of water by the molar mass of water, which is 18.016 grams per mole. This gives us 13.89 moles of water. Step 2. We must calculate delta T. To do this, take the final temperature of water, which in this case is 80 degrees Celsius, and subtract the initial temperature of water, which is 10 degrees Celsius. The change of temperature is then 70 degrees Celsius. Now substitute the relevant values we have obtained into the equation and solve. This gives us Q equals 73,214.19 joules. We can convert the number of joules to kilojoules by moving the decimal place 3 spaces to the left, giving us the answer.